Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm really happy about this because, again, I wasn't expecting to solve this on my own, but I did. So let me show you how I did it. This one is called Leftmost Column with at least one 1. So you're given a row sorted binary matrix where each element is either a 0 or a 1, and you're given this API here, and you want to find the leftmost column with at least a single 1 inside of it. So the easiest way to do this, and you just have to get used to the API, row column is X and Y, and then dimensions gives you everything. So let's come up with a brute force solution. We're looking for a column. So the answer is going to be either, so the first row is of this length, the answer is going to be somewhere one of these indexes, right? As long as it's a 1. So let's go ahead and get the dimensions, which is going to be our X and Y. So binary matrix dot dimensions, and let's print X and Y. So that's the row and the column limit. And then we can just say for I in range X, for J in range Y, just treat it like a regular matrix. And then the current value is going to be whatever you get. So you pass in this row and the column. So binary matrix dot get I and J. So if the value is 1, obviously we're trying to minimize something. So we're trying to find the minimum column. So this is a valid column. So this J is valid. So we update answer if it's smaller than answer. And then at the end, if answer never changes, then we return -1. Otherwise, we have the smallest column with the 1 inside of it, right? The leftmost. And this is technically working, but it's way too slow. What you want to do is make some observations instead. Okay, so if we take this, for example, take these examples, it's not immediately obvious that you have to do a binary search, but you notice that the 1s are always to the right of the 0s in each row, and that's the key to understanding this is a binary search. Because now what we're going to do is loop through every single row, and then like for each row, because the rows are going to look like this, we have a left and a right pointer, and then we're going to do a binary search on each row, and as soon as it's a 1, we're going to shrink the window to the right because we know that it's at least going to be this, and then we just keep shrinking until we get to a 0. And we know because the 1s are to the right of the 0s, then we can just end the binary search for that current row and then update whatever column that we found for the mid, right? So mid would be starting here, and then we do the binary search. So as long as we see a 1, we shrink the window this way. If we see a 0, we do the opposite, right? Left goes up to mid plus 1. Okay, so now let's go ahead and do that. So for I in range, let's get the rows, which is going to be X and Y, is binary matrix dot get or binary matrix dot dimensions, and then X is just going to be 0. Let's print I to make sure. Okay, so you have 2 rows, 0 and 1, 0 and 1, 0 and 1. Cool. So now what we're going to do is run a binary search on this row. So to get the left and right pointer, obviously we're going to start at index 0, and then the right pointer is just going to be the length of that row, which is just going to be it's supposed to be X, I think, because so X minus 1, because the length of each row is consistent. You don't have this row is of length 2, this row is of length 1, they're all of length 2, so that makes things easier. So cool. This is going to be the boundaries 0 and 1, for example, for this row. And then while left is less than or equal to right, we're going to declare a mid index. So mid is the index, and then we're going to say the current value is just going to be what? Is going to be the current rows. So now we have to figure out the current row we already have, that's I. So binary matrix dot get I, and then the column is the left and right. So row, remember, is vertical, column is left to right, the width. So that's going to be mid. And then now we can say if current is equal to 1, right? If we found a 1 here, then we're going to shrink because we're going to keep track of that because at least it has to be there. And then once we get to 0, we finish because all the 1s are to the right. So if current is equal to 1, then answer is minimum of answer and mid. That's the index. That's the left to right boundary. And then shrink the window. Otherwise, if we see a 0, increase the window, right? So binary search on each row. And then at the end, if answer is float of infinity, if it didn't change from the beginning, then there's not a real answer. There's not even a single 1 inside of the entire matrix. So we would just return -1. Otherwise, we just return the answer. So, and there you go. Passes all test cases. So again, I'm really happy that I solved this on my own without much struggle. And yeah, hopefully this was helpful. Thank you for watching and stay tuned for more.